Let us see the next question. Determine risk adjusted net present value of the following projects. Two projects have been given. Initial investment is provided to us. Life of the project is given. Annual cash inflow is given to us. CV, coefficient of variation, is given for both the projects. The company selects risk adjusted the rate of discount on the basis of CV. If CV is 0, the required rate of return is 10%. CV increases, required rate of return also increases. So for the different coefficient of variation, different required rate of return have been provided to us. And present value factor of year 1 to year 5. So in a simple language we can say that we have been provided with the PVIFA information. So over here, say we are required to make the computation of the NPV for each of the project. I request all of you to make the calculation of the NPV for project X, then I will do. Project Y, then I will do. That is a sequence in which we will do answer. Let us have understanding, let's say, how to make the calculation of answer. We have been provided with the information that say the life of the project is 5 years. First of all, I am explaining for project X. Year 1 to year 5. The cash flows are 70,000. Now, importantly, we have been provided with the information that what is the coefficient of variation of the project X. It is 1.20. Language of the question speaks that the company has decided that, say, based on the risk, we will determine what would be the required rate of return. As far as the project X is concerned, friends, its coefficient of variation is 1.2. So if at all the CV is 1.2, so the required rate of return would be 16%. So what will happen over here? We will apply the discounting rate 16% for the purpose of NPV calculation. Dear students, the term risk adjusted discounting rate, it means that had the risk, you require more return. That is what we understand is technically risk adjusted discounting rate. For project X, 16% is the discounting rate, and annuity factor is also ready-made provided to us, and it is mandatory that say we follow that only for doing answer. 70,000 into 3.274. So present value of the cash inflow comes to 2,29,180. This is present value of the cash inflow. From that, investment is deducted, 2,10,000, and difference of that is NPV. So it is 19,180. This is the way we can do answer for project X. Friends, you can show this answer alternatively like this. The presentation can be done like this also. Only I am showing you a shortcut presentation. If at all you want to do that in examination, it is present value of the cash inflow minus investment. So it is the annual cash flow into PVIFA at the rate of 16% for 5 years minus investment, that is 2,10,000. So the cash flows are discounted in present value term using the annuity factor. So it is 70,000 into 3.2740 minus 2,10,000. So 229,180 minus 2,10,000. So it comes to rupees 19,180. This is the way NPV of the project can be found. Now similarly we will do for project Y. So heading is calculation of NPV for project Y. This is the next thing that we have to do. Now let us see that in case of project Y, how do we do answer? Year 1 to year 5, again the recurring cash flow is 42,000. We have been provided that the project Y has coefficient of variation 0.80. If at all the CV is 0.8, the required rate of return is 14% and annuity factor is 3.433. So this is 14% and this is 3.433 into 42,000 is 144,186. So this is the present value of the cash inflow. Less investment. Amount of the investment is 1,20,000. And difference of both of them is NPV. 24186. This is the way the NPV for both the projects will be calculated. So friends, over here we just have to make the calculation of the NPV for project X and project Y. That is a question. And since both the NPVs are positive, so we understand that the projects are worth accepting. That an answer. Both the projects are worth accepting comma because NPV is positive. Full stop. This is the way we can write answer.